Okay, so is it visible?
Yes, ma'am.
Yeah, we will be today we'll be discussing about constructors and destructors. So today I'll discuss the constructor, the zero argument constructor, parameterized constructor, and the destructors. And tomorrow I'll be discussing the copy constructor. Okay, so this consider the first line, this example, that here we normally we have done this in normal programs, that whenever we write down something, we write down some variable, and we need to declare them, and we need to initialize them. That means we need to store some values. Okay, so our objective of using or doing creating this class is very similar. That means very similar to the built-in data types. That means we'll be creating class and its objects by keeping in our mind that what we normally do with the built-in data types. Built-in data types like int, character, floats, etc. What we normally do. So when we create any integer type variable or any float or character variable, we do two things. That is, first is we declare them. That is what is the type and the variable name. Like I have defined declared here int, this is the type, and variable name is a, and then we need to store some values in these variables. So here I have stored 10. So I can do it the declaration and definition in the same line, or we can do this in this way also. So here normally we are doing this thing. Now this is this program. Just a second. Okay, so this program here, I have written the normal C++ program where I have taken one class and two data members, two member function, normal member functions. Okay, so get data function is used to initialize the variables, that is sorry, age and role. So it is used to initialize the age and role. Okay, so first we need to declare them and then we need to define them. Okay, so we have declared here, and by this function we are defining. So how we are defining? Whenever we call any object along with the member function, we are passing some actual parameters, actual arguments, and those actual arguments are copied into the formal arguments, and then this age means x dot age, and this role means x dot role. So this thing we have done, isn't it? So we are normally what we are doing, we are declaring here this declaration, and this is how we are initializing or defining the variables, definition of the variables. Okay, next is, so far we have done this. So after the objects are created, here the value initialization occurs. So once you create the object, then you can initialize the object values. First we are creating for x, there are two places, that is age and role. Then we are initializing by calling this function. Okay. So can we do this thing at the same time like we are doing here, the declaration and initialization at the same time? Because we are following where normally we try to do the normal operations that we do with the built-in data types. So that is our objective of creating user-defined data types. That user-defined will act like the built-in data types. So built-in data types we can have declaration and initialization at the same time. So now here we are checking that this is done. This is first declaration is done, and then When the object is created, then the definition is done. So can we merge these two? That means whenever we create the object, that will get initialized. So this thing can be done, this particular requirement can be solved by using a special function that is known as constructors. Okay, so C++ provides a special member function that is used to initialize the objects during their creation. So this part is essential. So it is known as constructors. Okay. Similarly, another member function is used to destroy the objects. That means whatever objects are created within this scope of this class, they will be destroyed. Okay. So explicitly we can destroy the objects. So that is known as destructors. Okay. So till now we have used so many objects. We have created so many objects and we have done this initialization, etc. Okay. But is there any constructor used? Constructors. So this is a question. Okay. So next we are coming to this point. So constructors the points related to the constructor is the constructor gets called automatically whenever an object of its associated class is created. Okay. So this line is important. First line, the constructor gets called automatically whenever an object of its first class is created. So you have seen here, I have created one object. Okay. And I am telling that constructor gets called automatically, whereas constructor is a function, particular function. It is a special member function. It is a special member function. But can you find any other member function definition here? No. Other than these two, can you find any other member function definition? But I am telling that constructor gets called automatically whenever an object of its associated class is created. Okay. So how this works? So how this thing is true? How this point is true? Because it gets called automatically, but we need to define it. At least we need to define it, otherwise how it can be called. Okay, so I'm coming to answer this question. Next is the constructor name is same as the class name. Okay, so whenever we define constructor, whenever we write down our constructor definition here, whenever we write down, that will be having the same name as the class name. Okay. So if I have a class called integer, the constructor will be like this. It is a member function. It will be like the same name as integer. Okay. It is called constructor as it constructs and initializes the objects at the time of their creation. So how they does it? So this is the purpose and these are the different characteristics. Okay. So next I'm coming to answer you the question that whenever you don't have any constructor written there. So I have not written anything like student. So you see that here one constructor is written called integer. Okay. And we have written some body for this constructor. So now if integer object is called, this integer function, this function integer, this constructor, this is rather we say this as a constructor. So this constructor will be called automatically. But here you see there is no constructor. But how then this thing will be calling it? Okay. So it appears, the constructor appears as the member function of each class when it is defined, whether it is defined or not. Okay. So this constructor, it appears as member function of each class whether it is defined or not. That means whenever we don't have any explicitly defined constructor like student, if we don't have anything like this, then the compiler supplies us one constructor. Okay. So till now we have not used any constructor. It seems we have not written any constructor, but it is not like that we have not used. Constructor has provided a default constructor whenever we have created any object. Okay. So that is known as default constructor. We will discuss this thing. later in detail. Okay, so constructor may or may not take parameters, and it does not return anything, not even void. Okay, so you remember these two things. Constructor may take parameters, but it does not return anything, not even void. Okay, and the prototype of constructor is the class name and the parameter list. So if this is integer, so this is integer, then the parameter list. It may or may not contain parameter. Here it is void, but it may contain parameters. Okay. So constructors, they fulfill the need of a function that guarantees initialization of the member data of a class, and it allocates space, or it can set data members to default to a default value. Like here, these data members m and n are initialized. You can initialize them, okay, the data members of a class using the constructor. So the names, as the name suggests, the constructor actually initializes the or constructs the object whenever they are created. And whenever you created any object, say integer I, so whenever you create some object integer I1, say, so that time this will be called automatically. The constructor will be called automatically. Okay, no need to call it explicitly like I1 dot integer. So whenever you create this one, so this particular statement, the compiler will convert this statement as this I1 dot integer. It will call this constructor function. Okay, and the constructor can initialize this parameter with any value. Here I have initialized with 0, but it can initialize with any value. You can also pass some values to initialize. Okay, now the last point is that the domain constraint on the values of data members can also be implemented via constructor. So what is a domain constraint? Okay, say for example, I have taken two examples. Say consider a class clock having members hours, minutes and seconds. So if I have a class called clock and say I am having int hour, int minute and int second. Okay, so now if I have any function here if I have any function called get data, which initializes all these three values. Now the domain constraint is, here the domain constraint is hour can be from 1 to 24. Hour can have value from 1 to 24. This is the range of values it can take. Minute can take from 0 to 16. Okay, second can take values from 0 to 60. If it is so, or consider a class distance having feet and inches. Okay, so we know that feet is 12 inches. Inches is 12 inches means 1 feet. So we know that. Okay. So if I or say in a calendar, if we are creating a calendar class where we are having month, then day, etc. Month and day. So month, the constraint is we can take up to 1 to 12. For day we can take 1 to 7, 1 to 30, 31, like this. Say we are creating a date class, not calendar. We are creating a date class. So year, month and day. If I have year. Okay. So the domain constraint means we normally know that the value of or the domain of month is 1 to 12. That month can take this many value, or hour can take 1 to 24. Now with a get data function by which we are initializing this hour, minute and second, can you guarantee that hour will not contain 35? If I initialize this with for get data, if I initialize hour equals to 35, no error. Are you getting my point? There is no error.
Yes,
I
ma'am.
can initialize 35, but we cannot protect this constraint. We cannot do this constraint, but with constructor we can protect this. We can in constructors we can normally pass values. We can normally initialize the hour. Okay, so we can maintain these things. So domain constraints on the values of data members can also be implemented via constructors. We can maintain it. Okay, the domain constraint means no, if I maintain this one with a constructor, well-defined constructor, then hour can take 1 to 24. If I can program this, it will take from 1 to 24 only. And if I have some data like this, it can have any value. Okay. So next is the default constructor that I am talking with. So till now we are using the type of statement, create object student A. Okay. Say, so A is an object of student. Now whenever we create this type of object, compiler supplies one constructor by default that accepts no parameter. Okay. So this call is converted with this type of statement and then this type of statement. Okay, so the later part I'm coming later. Okay, so it will convert, for simplicity let us understand this one. It will convert to this type of statement. Okay, that means it is calling a constructor, and we know that constructor having same name as the class, that's why its name is this. It can pass parameter or it cannot pass parameter. Okay, so default constructor, they do not have any parameter. So this is known as default constructor, and this is defined in this way. Okay, so explicitly when out of the class we are defining, then we can define it class name, then scope resolution, then function name, and then argument and the function body. Okay, so either you can pass parameter, either you can write down something, or you can write down zeros. We can initialize the variables as zeros, etc. So if there is no constructor explicitly defined, that means if you are not writing your own constructor, then compiler supplies the default constructor, and that is how these programs work. Okay, so constructor is supplying some default constructor. So the default constructor only could perform the storage allocation, but no initialization is possible, or sometimes it initializes to 0. Okay, and the constructor is a non-static member function, and it is called for an object. Okay, so always the constructor is called for whenever an object is created. Whenever we create any object, say student S1, then only the constructor is called. Here, then only the constructor is called. Okay, so this object is used. Always the object is used to call. Okay, so it takes this pointer as a leading formal argument. So do you know what is this pointer?
It points to the current object.
Yeah, those who don't know, just I am giving you a little bit of idea about this pointer. Okay, and then sir is going to take this pointer class and reference class. He will be telling you in details. This pointer is it is a pointer that whenever you say we are calling this s1 dot get data, so the object which is used to call any member function, this pointer points to this object. That means it actually refers to the current object that is calling the function. Okay, and it is written as this. Its name is this pointer. Start this. Okay, this pointer. So we need not to explicitly write it down. Rather, whenever any object is called with the reference, so this pointer always refers to the calling object, and its reference is passed within the function. Automatically the reference is passed within the function. So within get data, if I say here, let us take this example. Here in this get data, if I write here within get data function, if I write this dot age, that means also this dot age means which object it is calling, x it is calling, so this refers to this x. Okay, say we are having another object, say y. Okay, so if I called y dot get data, so that time this dot age means that this will be pointing to y, because y is here used to call the function. Are you getting my point? Understand this thing? Yes.
Yes, ma'am.
Yes. So this pointer always points to the object, okay, which is used to call the member function. So this pointer is having a very important use in the constructors. Okay, so we can refer them. Okay, so constructors also, whenever we use constructors, it is called by an object, and that object, this pointer is points to the leading, it points as the leading formal argument. That means, say I'm having one object a, and I am calling with this object I am calling our constructor. Okay, so in the constructor this a is passed automatically, and we can use this pointer to refer that object. So if I calling a dot say student, this is called, this a reference of this a is called automatically, passed automatically, and it is used as the first argument. Okay, leading formal argument, that means the first argument. It may happen that we are passing some more argument here. Okay, so it will be used as a first argument. So I'm coming to this thing later. Okay, when we study copy constructor and in details that this pointer, this point will be, you will be understanding. Okay, and then the address of invoking object is passed as a leading parameter to the constructor call, the same thing, and this means the member of invoking object can be accessed from within the definition of the constructor. So this is very obvious that member of the invoking object can be accessed, because our aim is to initialize the members of the invoking object using these constructors. Okay. So next is a zero argument constructor. So the constructor that does not take any argument is called the zero argument constructor. Okay. So zero argument constructors also, it may be known as the default constructor. Okay, they can be used interchangeably, because the default constructor also by default they do not take any argument. Okay, so here I have written a zero argument constructor, that is our own constructor. Okay, I have written this one, so you just consider line by line. So these things, you know, here one class and one int x. Okay, and I have written this constructor, I have written it explicitly. Okay, I'm writing my own constructors. So I'm writing this thing, this is the declaration, and then we are defining it. So this is the definition. Okay, so I'll be writing this. This is the class name, scope resolution, constructor name. It is not passing any argument, and I'm just printing this constructor of class A is called, and this endl. Okay, now here again we are calling this one, see, a1. Okay, so whenever I call the object, whenever any object is called, the constructor will be called automatically. Okay, now as we are having our default constructor, as we are having written the constructor explicitly, so our computer will execute this one. So till now we don't have anything, so compiler is providing us the constructor. Okay, so let us see this one. Say just a second. So let us write it down. Okay, so I'm running it. So it is giving this one, constructor of class A is called, and then end of the program. Okay, next, say for example, say I'm not having this constructor. Okay, so I'm not writing this constructor. So let us see what happened. Okay, so that is the previous program. Okay, so here if I am running, it is not giving any error even if the constructor is not there, our own constructor is not explicitly written. Compiler is providing one default constructor. Okay, then it is either it is storing a value of x as 0 or some garbage value or something else. Okay, but it is running fine. So it is a good practice to use constructors and to define our own. Okay, so here I am defining our own constructor. We can also write it down like x equals to 10. Here we can also write it down x equals to 10. So constructor a class A is called. Then we can write down the value here. So if I run it, it is saying that constructor class A is called x equals to 10, and then we are coming out end of this program. Okay, so are you getting my point how constructor is called?
Yes, ma'am.
And we can write down our own. Okay, so from now onwards you will try to construct your constructors rather than writing get data or put data, this type of set data functions that initializes the data members of your object. You try to include your constructors. Next coming to this point, that constructors are called for every object in the similar manner. Okay, and objects are declared or created before the constructor is called. Okay, so this point is very important. The objects are declared or created before a constructor is called. Here we are not finding the difference that when it is called and when it is declared. But what happened inside, whenever we declared any object, okay, it is called first, then the constructor is called. Okay, so that is the order by which they are called. So next is, let us take one more example. So here you see there is one class called display IC, where I have taken two parameters, two data members, okay, X and character C, and I have called this constructor display IC, and two member functions, get X that returns X and get C that returns the character C. Okay, now see this one, the definition of display IC. In this definition I have defined X as 10 and C as Z. Okay, so now if I call this D1, what it gives, what it does, D1, whenever D1 is called, it calls this display IC. D1 is converted to this display IC. Okay, and this is called an x d1.x and d1.c is initialized to 10 and z. Now if you call some more object, they will do the same. And if you print this get x and get y, get c, it is printing 10 and z. This is fine. Okay, now my point is, can we write down the constructor in the private section? What is your idea? Can you write down or define or declare the constructor in the private section? We every time we are defining them in the public section. See here also I have defined it in the public section. And I told that it will always be declared in the public section. But why? If I define it inside the private section, what happens? What is your logic? Tell me. Can
And
we do that?
since it is being called from outside, so we need to have it in public.
Exactly. We know that whenever the object is created, at the very same time the constructor is called. Now the object is created inside main, that is outside the class. So whatever be outside the class, we can call from outside only the public functions. We cannot call them the private function directly. But as the constructors are called automatically, so we need to put them in public, otherwise it will give some error. Okay, so that is the reason. So we declare the constructor in any section, but when creating the object, we do it outside the class definition. So during object creation, constructor is called, but you cannot call any function from outside the class if that resides in private. So that is the reason. Okay. So this is why we should not write down the constructor in the private section. Okay. You understand this thing? So next is Acha, next is one more thing. That is, if I say now create D1. Let us see this example. I have already written this. Yeah. So this one. So if I run it, let us run it. So this one. So that part is over. I already discussed you. If I write it down here in the private section, the display IC, it will give some error. Okay. Now say for example, if I want to create one more constructor. Okay. Say I have created D1. Next I am say creating display IC D2. Okay. And I am just printing them. So if I run it, so what it is giving? Though so the for sorry D2. So this is for D. So if I run it, so first one is for D1 and second one is for D2, but both are having same values. If I want my D1 and D2 will be having two different values. Can we do that? Using this function? Are you getting my question?
Yes, ma'am.
Say I am creating D1. Okay, this is fine. For D1, it is taking a 10 and for C, it is taking Z. But for D2, I want that X must take 20 and C will be Y. Okay. So can we do that using this function, because I have already defined this thing. So can we do this thing for D2, some other values?
Yes, ma'am. We can change it in the class.
We can change it in the class here. If I change it in the class, then if I run it, it is for D1 also it is taking 20 and Y. I want D1 to be having say a different value and D2 to be having different value.
We need to declare two constructor.
We need to develop two constructor. Okay. So if I develop one more constructor, and I'm writing down the previous values here. So if I run it, see what happened. Which one is to call?
We have to pass argument.
There is one error. Okay. Because both the function having same name, only the body is different. So D1 and D2 are confused. There is one ambiguous call. They don't know which one to call. The first one or second one. That's why they are giving some error.
We have to include arguments in the declaring constructor part of the class.
Exactly. We know that constructor can take arguments and can or cannot take an argument. So now next comes the idea of having arguments. Okay. Now whenever you have seen that we can have similar function names but different arguments. What it is known as? If I
Function overloading.
Exactly. So the idea of function overloading is necessary, and whenever we pass parameters to the constructor, they are known as parameterized constructor. Okay. So the parameterized constructor, they totally depends on the idea of having on the idea of function overloading. You got my point? So we'll be having different constructors. We can have different constructor, any type of constructor, any number of constructors, and we can differentiate them by using the different values that we are passing. Like here, I can develop this display IC function so that it can take values for is D1 and D2, separate values for D1 and separate value for D2. Okay. And this depends on the idea of function overloading. I think all of you know what is function overloading. Same function, having same name, but different arguments, different number of arguments, different order of the arguments, and they're having different purpose. So rather than passing zeros, we can use numbers to assign them as values, and by passing arguments to the constructor, this can be done. So now we introduced the parameterized constructor where all the other properties are same, just we are passing some parameters. So if you are passing parameters, integer x, and we can initialize them using this one. Okay. So parameterized constructor is prototype and defined just like any other member function, except the fact that they does not return any value. Okay. We can pass the arguments in two ways. Okay, we have to pass the initial values for these arguments. So we can pass them in two ways. Either calling the constructor explicitly or calling the constructor implicitly. So previously we used to call the objects in this way: integer I1, I2, I3. Okay, but now whenever we are passing parameter, whenever we are having parameterized constructor to match with this prototype, we need to pass some arguments, the actual arguments, and we can pass the actual arguments by two ways. One is this explicit way, another is this implicit way. So the implicit way looks like looks good. It is good, means easily readable, and it looks like good, like we are passing something. Okay, but it's not like function. You understand this thing? We are calling object and we are passing values. It look like a function that we are calling a function, but it's not like that. This particular argument, this particular line will be converted to I dot integer and then 0 and 100. So that will be again called here, and 0 and 100 will be mapped to x and y, and x and y will be 0 and 100. Okay. So now it serves our purpose with this display IC. With this display IC. Now if I have this display IC and having parameters like int x and say int I and say character, int I and character. Okay. And if I write it down, like if I define it, int I car, say CC. Okay. And if I put here this as this, so if I change them, like we are passing something, let's say 10 and z, here I am passing say 20 and say y, must work. Okay, yeah, having something like that. Int say int I and int CC, something like that. This is not exactly correct. Okay, just I'm making the changes for this. Okay, so according to our theory, it must work now, this one and this one. So we can initialize them with different values. Are you getting my point?
Yes.
So here is one rule actually. If I run it, it will not work. There is one rule that we need to remember. That is, if a parameterized constructor is provided, please switch off your microphones. It is echoing actually. My voice is echoing. So if the parameterized constructor is provided and the zero argument constructor is not provided, the compiler will not provide the default constructor. Okay. So this, so the as the function overloading works here, so we need to define all the roles. If you are providing the zero argument, if you are providing parameterized constructor, but not the zero argument, okay, so here compiler will not understand that we need to provide the default constructor. Okay, so that is one thing. That means, say for example, if you are having some integer like this, integer I1, we are passing with 0 and 100, I2 we are passing with 10 and 20. Okay, but we are normally calling I3. So I3 will not match with any constructor if you are not providing default constructor. And compiler is not going to pass this default constructor if we are having parameterized constructor, explicitly defined parameterized constructor. Compiler thinks that you are having the copies of constructors, so you can manage. Okay, so it not need to send the default constructor, but it will not send the default constructor. So that time it is mandatory to define the default constructors if you are using parameterized constructor. So this is the rule. Okay. So for this program, we need to write it down one default constructor also. Okay, display IC default constructor that we have to define. That is, say is either you write down something or you can just place it like this. Okay, so this one is important. So let us run it. Let's see what errors it is giving. Some error it will give. Yeah, I think type mismatch and other errors it will be giving. Yes. It is giving some error. Okay, two definitions I have taken same. That's why it is taking. It's not running. Yeah. Now see this one. Are you getting this?
Yes, ma'am.
This one, see. For D1, D2. So now it is running. And what was our idea? That to have different values for D1 and D2. Now we are getting this with the single constructors. Okay. Now say if I have this one, sorry, say if I have one more, say D3, and we are not passing anything. Okay. Then also it will work. If you write down here, default called. If I write down this one, see, I run it. Sorry, this one is. Okay, so for D1, D3, default is called. For D1 and D2, this constructor is called. Okay, so if you are not writing anything, that means I am just written one sentence to make you understand that the default, how the default is called. So for D3, the default is called. Okay, and if you are not writing anything, if you are not providing the default constructor, see what happens. It is giving error. It is not finding any definition for D3. Okay. Even if you are not using D3, if you are using this one, then also it will give some error. It must give some error. Okay. So ideally it must give some error. I don't know whether maybe this compiler is not giving error, but it must give the error. Okay. So this one is essential, even if you are writing your own constructor. So you understand this thing, this part? So here I have taken one example for this integer. So this one is the explicit declaration, this one implicit, this one this will call the default. Okay. So this is what. So even if we are not writing down this one, this giving, if you are just commenting out this one, it will give some error. So the same program I have written there. So you understand this thing, this part?
Yes, ma'am.
Is there any query regarding the constructor? So now when we write down our own program, now we can call our constructors and we can initialize our objects during their creation. Okay, so no need to write down put data or get data, this type of functions. Okay. So do you have any other class from 11?
Yes, ma'am.
Okay, so let's stop here today. Tomorrow I'll be showing you the copy constructor. That is here we have past normal variables. Okay, but can we have this type of thing? That means can we have one constructor that I have created, I3 I have created. Can we have some constructor like I4 is initialized with I3? Can we do this? Because normally in normal variables we can write it down like this, na, int a. If I initialize int a, then if I write down int b equals to a, so the value of a gets copied to b. So is it possible if we write down integer I4 equals to I3, so that all the values of I3 gets copied to I4? Okay, so is it possible? So if I show you some program, so this is one program, say this one. So can we do this thing? This one. So this one is done. This one can be done. So for x1, the default one is called. For x2, 10 gets initialized with x2 with this parameter is constructor, and for x3 also it is giving a equals to 10, because as the compiler is passing, it is providing one default copy constructor. Copy constructor means two words, that is copy and constructor. So construction, copy constructor, sorry. Copy constructor. Oof. So here two words are used. That means we'll be constructing the object, by copying some other object of the same class. Okay, that's why it is known as copy constructor. So we'll be checking out this thing. If I initialize an object from another object, what are the different problems we can face? Okay, so default copy constructor works fine. Here it will do the thing, but there will be some problems. Okay, we'll be discussing them tomorrow. Okay, so till now, is there any query? Yes, anything?